Hello everybody, welcome into another lesson. So today we are going to talk about the determinant of a 3 by 3 matrix, the normal method. Next lesson we'll do expansion of cofactors, but this lesson we're going to do the normal method for evaluating the determinant of a 3 by 3 matrix. So here you have matrix A with your arbitrary constants in them. Of course, to evaluate the determinant, you're going to do it much like you did with the 2 by 2. You're going to take all the entries in the matrix, put it into what looks like a big absolute value sign. Now here's where it gets different. So up here you see what we call the coefficient matrix. When doing a determinant of a 3 by 3 or larger, the signs alternate for each of the entries. So you have positive, negative, positive, negative, positive, negative, positive, negative, positive. So what does that mean? When you evaluate the determinant of a 3 by 3 or larger matrix, what you can do is you can either do it by row or column, but I usually choose the row since it's easier. I stick with row 1. So the determinant is going to be equal to your first coefficient in your first row of A. Now, when you use that particular coefficient in a row, what you're going to do, if it helps you, take a marker or take a pencil or something. What you temporarily need to do is strike out that column and strike out the row you're using, because it's going to be A times the determinant of what's left over. So when you use a particular coefficient, you strike out the row and the column you're using. It's that coefficient you're using times the determinant of whatever's left. So in this case it would be A times the determinant of EFHI. So you still are doing plus A times the determinant of EFHI. Now, that's only part 1. ADG. Let me rebuild this here. I'm going to have to rebuild this several times, but I want to show you the right way. Okay, so that's the first part. Now, according to your coefficient matrix, it's going to be minus, if we're sticking with the row, minus that B coefficient times the determinant of what's left over. So remember, when you're using a particular coefficient, you're going to strike out the row it's in and the column it occurs in. So it would be minus that B coefficient times the determinant of whatever's left, which would be DFGI. Then there's one more. Since it's a 3 by 3, you're going to do a third multiplication. Alright, so then for the final part, according to the coefficient matrix, it's going to be plus your C entry. So plus your C entry, so you're going to strike out the column and the row that C is in, and it'll be the determinant of whatever's left over. So plus C times your determinant of D, E, G, and H. So what you got is the determinant of a 3 by 3 matrix here using the normal classic method. You're going to have 3 coefficients with alternating signs times 3 2 by 2 determinants. So let's get into some examples here. I am going to leave this coefficient matrix up to aid us in what we're about to do. It's going to help immensely. So let's go ahead here and set up our determinants. So first one, you have 12, 4, -1 for the first row, -2, 3, and 2, and then 5, 8, and 1. Is that +1? Yes. Okay. So matrix A has entries 12, 4, -1, -2, 3, 2, 5, 8, and 1. So we are going to evaluate the determinant of this 3 by 3 matrix. So we will set up, of course, what looks like that giant absolute value sign. You take all these entries and put it inside of that. Okay. So now we've put it inside that giant absolute value sign. So what are we going to do now? We'll start with the sign of what you're going to do. You can go down the column and use the numbers in one column, or you can go across the row. It really doesn't matter. I choose the row. It's easier for me to do it in the row. Heck, you could do it diagonally if you really wanted to, but you're more likely to make mistakes. But you could pick any row, any column that you want. You could do the second row if you wanted, the third row, or second column, third column for your to do the expansion. But I always like to pick the first row. It makes it the easiest. So take your sign here, which is positive, for the corresponding to the first number of the coefficient of your number in the first row. So this is going to be positive 12, so just 12 times a 2 by 2 determinant of whatever's left. So remember, take the column in the row that number's in and strike them out. Okay? That'll give you positive 12 times the determinant of whatever's left, which would be that 3, 2, 8, and 1. Okay? So there's the first part. I'm going to have to do some erasing here and stuff, but I want to show you in a way that makes sense. And now, if you can mentally check them off in your mind, that's great, but it sometimes helps to strike them so it's not so hard. Okay. We're working in the first row, so the next coefficient is going to be 4. You have a positive 4 in the determinant, but according to the coefficient matrix, you need to negate that 4. So it'll be -4 times the determinant of whatever's left over. So once again, strike out the column that 4 is in, and then the row it occurs in. Which now will give you the determinant of -2, 2, 5, and 1, okay? And then we got one more number in the first row we got to do. Alright, so then the last number in the first row is -1. And according to the sign matrix, you would have a positive. So positive -1 is still -1 times the determinant of whatever's left over. So strike out the column that -1 occurs in and the row, which would give you what's left over, the determinant of -2, 3, 5, and 8. So this becomes 3 2 by 2 determinants multiplied by some numbers. So let's go ahead and deal with this. So we'll take 12 times the first determinant. I probably better stay away from brackets here. let's do some large parentheses. So 12 times the first determinant, 3 times 1, minus 2 times 8. There's your first one, minus 4 times the determinant of this here, negative 2 times 1, minus 2 times 5. Then you have minus 1, which would just be minus negative 2 times 8, minus 3 times 5. Now we just have a bunch of order of operations. Well, of course, let's start in the parentheses. You'll still have 12 times whatever's inside of here. 3 times 1 is 3, minus 2 times 8, that'd be minus 16. Minus 4 times negative 2 times 1 is negative 2, minus 2 times 5, that'd be minus 10. Minus, and here, negative 2 times 8 is negative 16. Minus 3 times 5 is negative 15. Alright, so then you're going to end up having 12 times, what is 3 minus 16? That's negative 13. Minus 4 times negative 2 minus 10 is negative 12. Minus negative 16 minus 15 would be negative 31. Alright, so 12 times negative 13, that's going to be negative 156. Minus 4 times negative 12, that'd be plus 48. Minus 31 is plus 31. Alright, so negative 156 plus 48, that's going to be negative 108 plus 31 would be negative 77. So the value of this determinant in the end would be negative 77. So yes, all that work to get negative 77. All right, I got plenty more where that came from. Whoops, I did not mean to erase my coefficient matrix. I'll set that back up real quick. Just give me a minute here. I'm definitely not trying to erase that. Always keep that up. That might help you. All right. Oh, excellent. Excellent. All right. So we have this matrix here, 5, negative 9, 4, 4, 2, 1, 0, 1, 1. All right, well, our lives just got easier since we have a zero entry. I'm going to show you how. So, to evaluate the determinant, take everything, set it inside, of course, your absolute value. Your big, it's not the absolute value, but a big absolute value looking sign. All right. Remember how I said we can pick any row or any column or even the diagonals if we so choose? Well, that means we can pick the third row. Why don't we pick the third row? The reason I'm saying that is because you have a 0. And we know 0 times anything is 0. So that's only going to leave us with 2 2x2 determinants to evaluate. That's going to make our lives a lot easier. If you have a 0 row or column, a 0 in it, you can use that to make your life so much easier so you don't have to do as much work. So we're going to go down the third row. We know 0 times anything is 0, but let's start there. The sign would be positive, which means the sign on the one we're about to do would actually be negative. So you have a positive 1 in here, negate that, you'll get negative 1. Now, we're working in the third row here. So strike out the row that 1 is in, and then the column. That's going to give you the determinant of whatever's left over, which would be 5, 4, 4, 1. All right. And then we have, that means we're going to have one more 2 by 2 determinant to evaluate. You have a positive 1 in this determinant, and according to the coefficient matrix, the sign on it would be positive 1. So you have positive 1 times the determinant of whatever's left over. So let's go ahead, strike out the row that 1's in and the column. Now you have the 2 by 2 determinant of whatever's left. So you would have 5, negative 9, and then 4, 2. So now you only have 2 by 2 determinants to evaluate, as opposed to picking any other row or column, which would give you 3. So let's evaluate those. The negative 1 is literally just negating the determinant of what's here. So we take 5 times 1 minus 4 times 4 plus this determinant here, 5 times 2 minus negative 9 times 4. Okay, let's just deal with our parentheses first. So 5 times 1 is 5. Minus 4 times 4 is negative 16. So negative of 5 minus 16 plus, then we have 5 times 2 is 10. Negative 9 is positive 9 times 4 is 36. So 10 plus 36, which would give you the negative of 5 minus 16, which is negative 11, plus 10 plus 36, which is 46, which would end up giving negative 11 is positive 11. So you'd have 11 plus 46, which would give you a determinant value of 57. So the determinant of this particular matrix is going to be 57. All right, what's the next one have in store for us? Alright, so matrix A has entries 0, 5, 2, 10, 13, negative 4, negative 5, 4, negative 1. So I think, again, we want to go with the row that has a 0 in it, which is going to make our lives a lot easier. Then we're down to 2 by 2 determinants as opposed to 3. So, of course, let's evaluate the determinant of this. So take all your entries, put it into that big absolute value looking sign. Okay, so of course 0 times anything is 0, so we just need to worry about the 5 and 2. Well, according to your coefficient matrix, you're going to take that 5 and put the negative on that. So you're actually going to have negative 5 times the determinant. So strike out the column and the row that 5 occurs in. You have the determinant of whatever's left over. So you'll have 10, negative 4, negative 5, and negative 1. All right. Let's go ahead and rebuild this real quick. Okay, so let's see. That means our last entry should be then, our last one should be a 2. And according to the coefficient matrix, you're going to have a positive 2. So that would be plus 2 times the determinant of whatever's left over. So strike out the column and the row that 2 occurs in. It's the 2 by 2 determinant of whatever's left over. So this will become the determinant of 10, 13, negative 5, and 4. Alright, now we'll just do these determinants here. So, of course, you have negative 5 on the outside of the first determinant, so take 10 times negative 1 minus the negative 4 times negative 5 plus 2 times that 10 times 4 minus 13 times negative 5. Alright, so let's work inside of our parentheses here. So let's see, negative 5 times what's inside of here. 10 times negative 1 is going to be negative 10. Negative 4 is positive 4 times negative 5, that'd be minus 20. Plus 2 times, let's see, what's inside of this? So 10 times 4 is 40. Negative 13 times negative 5, that'd be plus 65. Okay. Which would turn into negative 5 times negative 30 plus 2 times 40 plus 65, that'd be 105. So negative 5 times negative 30 is positive 150, plus 2 times 105, that'd be 210, which would end up giving you a determinant of 360. So the determinant of this matrix would in fact be 360. I may need another black marker. There we go. All right. Alright, so here's your next matrix with entries 1, 16, negative 2, 24, 2, 7, 1, negative 4. So let's evaluate the determinant of this. So take all your entries of the matrix, put into this absolute value like sign. Okay, Unfortunately, we don't have any zero entries, so we're going to have 3 2x2 determinants to deal with. I'm just going to pick everything in row 1. I'm going to start with the coefficient 1, which according to my coefficient matrix should stay positive. So that would just simply be the determinant of that 1, which 1 times anything is itself. Now strike out the row and column that that 1 lies in. 1 times the determinant of whatever's left over, which would be that 4, 2, 1, and negative 4. Okay. Now let's rebuild this real quick here. Whoops, wrong color. I want to keep it. All right. Now we're still working in row 1 here. So the next one in row 1 that we're going to use coefficient wise is 16. But according to my coefficient matrix, I need to negate that 16. So it'll be minus 16 times the determinant of whatever's left over. So strike out the column and the row that that 16 occurs in. It's going to be minus 16 times the determinant of whatever's left, which would be 22, 7, and negative 4. All right. Let's rebuild this again here. Now the last coefficient we're going to use in row 1 is negative 2. So we have a negative 2, and according to my sign matrix, that's plus. So I'm going to take positive negative 2, which would still keep it negative 2, times the determinant of whatever's left over. So strike out the column and row that negative 2 occurs. Now it's times the determinant of whatever's left. So it'll be 24, 7, and 1. All right, so now we have our 3 2x2 determinants to work with. So let's see. The first one, 4 times negative 4 minus 2 times 1. Now minus 16 times this determinant, 20 times negative 4, minus 2 times 7, minus 2 times this determinant, 20 times 1, minus 4 times 7, alright, so let's work inside our parentheses here. 4 times negative 4 is negative 16, minus 2 times 1, that's minus 2. Then we have minus 16 times whatever's inside of here. 20 times negative 4 is negative 80. Minus 2 times 7, which is minus 14. Then we have minus 2 times, let's see, 20 times 1 is 20. Minus 4 times 7, that's minus 28. So let's see. Negative 16 minus 2 is negative 18. Minus 16 times negative 80 minus 14, that's negative 94. Minus 2 times 20 minus 28 is negative 8, which would give you negative 18. Now, whatever that is, negative 16 times negative 94 is going to be god-awful, I guarantee it. Yep, 1,504. Negative 2 times negative 8, that's plus 16. So let's go ahead, add all these up, and you're going to have a high number. The value of the determinant is going to be 1,502, or 1,502. that is the determinant of this matrix, would be 1502. That is a lot. Oh, really good one. Alright, so matrix A has negative entries -4, 0, -1, 0, 8, 9, 0, 5, 2. So let's go ahead and set up our determinant notation for this matrix. We really lucked out with this matrix. You know why? Because, as I said, you can pick any row or column you want to expand this. If you look at column 1, you have 2 zeros, which means if we stick with column 1, you only need to consider that -4. Isn't that nice? You have 2 zeros, so you only got to do one 2x2 determinant, in other words. So we have a -4 for the coefficient in column 1. So according to our coefficient matrix, that's positive. So positive -4 is still -4. Now, still, you're going to strike out the row and column that it's in. And it's the determinant of whatever's left over. So that'll be the 2x2 determinant of 8, 9, 5, and 2. Alright, so let's evaluate that. You'll have -4 times 8 times 2 is 6. Well, 8 times 2. Let's just do that. Minus that 9 times 5, which would be -4 times 16 minus 45, which would be -4 times -29, which would be positive 116. So the determinant in this case is positive 116. That's quite nice. We just stuck with one column. We only had to do one 2x2 determinant. So again, work smarter, not harder, if you can. If you have a row or column with a bunch of 0 entries, take full advantage of that. 4 more, then we're done. Now this next one, they're not as nice. We have no 0 entries in this one, so we're going to have 3 2x2 determinants to do, but this matrix, you have entries 8, 2, 9, 12, 3, 9, 3, 13, and 4. So let's go ahead and find the determinant of this matrix. So set up your determinant notation for this. Okay. So we're going to work in the first row. So we have a positive 8 for the coefficient. And according to our coefficient matrix, it's positive times positive 8. So that would just stay 8 times the determinant of whatever's left over. So strike out the row and column that 8 occurs in. Here's what's left over. You end up having the 2 by 2 determinant of 3, 9, 13, and 4. Alright, so let's go ahead and rebuild this determinant here. Alright, so next we'll work with that coefficient of 2. According to the coefficient matrix, it'll be negative times that positive 2, so that'd be minus 2 times the determinant of whatever's left over. So strike out the row and column that it lies in. There's what's left over. You have 12, 9, 3, and 4. Okay? And then we got one more. Alright, so now we'll deal with that 9 in the first row. So we have a positive 9, and then according to the coefficient matrix, it's going to be positive times positive 9, so that would be plus 9 times whatever's left over for the 2 by 2 determinant. So strike out the row and column it occurs in. There is your determinant of whatever's left over. So that would be 12, 3, 3, and 13. Alright, so there's your 3 2 by 2 determinants. So let's get started. So we'll take 8 times 3 times 4 is 12 minus, whoops, I don't want to go that far yet. Let's just keep it where it is now. 3 times 4 minus 9 times 13 minus 2 times, let's see, 12 times 4 minus 9 times 3 plus 9 times, let's see, 12 times 13 minus 3 times 3. Alright, so let's work in our parentheses. 8 times, let's see, 3 times 4 is 12. Minus 9 times 13, that would be 117. Minus 2 times, let's see, 12 times 4 is 48. Minus 9 times 3, that'd be minus 27. Plus 9 times, let's see, 12 times 13 is 156, minus 3 times 3, which is 9. Okay. 8 times, let's see, 12 times negative, 12 minus 117 is going to be negative 105. Minus 2 times, let's see, 48 minus 27, that's going to be 21. Plus 9 times, let's see, 156 minus 9 is 147. We're almost there. Now we just need to figure out what the heck. I think that's going to be negative 840. I just want to be sure. Yep. Negative 840 minus 42 plus, let's figure out 147 times 9. $1,323. Which now let's just add all these together here. So 1,323 minus 42 minus 840, that would give you 441. So the determinant of this particular matrix would be 441. Yeah, that's a large one. Okay, we're on the last 3 problems, then we're done with this lesson. But you have a 3 by 3 matrix A that has entries 3, 12, -1, 10, 9, 0, -5, 6, -2. Well, good news is we have a 0 entry. I'm going to do all of row 2, but 0 times anything is 0. So that's going to make our lives a little bit easier. That's one less determinant to have to evaluate. So let me set up the determinant notation of all this. Okay, so we're working in that row and column, so that row, so let's start with 10. Well, according to my coefficient matrix, I need to take a negative and multiply it by that positive 10, so it's going to be -10 times a 2 by 2 determinant here. So strike out the row and the column it occurs in. Here's what's left. You'll have 12, -1, and then 6, -2. Alright, so now we got that 9 in the rows too. So we have a positive 9, and according to our coefficient matrix, positive times positive is still positive. So that'll be +9 times the determinant of whatever's left over. So strike out the row it occurs in and the column. And then there's your determinant of what's left. 3, -1, -5, -2. And then 0 times anything is 0, so we just got to deal with these two. So we'll take -10 times, now let's do our determinant. 12 times -2 minus -1 times 6 plus 9 times, let's see, 3 times -2 minus -1 times -5. So let's do with our parentheses here. 12 times -2 is -24. -1 is +1 times 6, that's +6. Plus 9. Let's see, times 3 times -2 is -6. -1 is +1 times -5, that'd be -5. So then we have -10 times -18 plus 9 times -11, which would give you -108. Actually, that'd be +180, excuse me. -10 times -18 is +180. Minus 99, which would give you a determinant value of 81. So the determinant of this matrix ends up being 81. Should just have 2 more, then we'll be done with this lesson. All right. Alright, so here's our next 3 by 3 matrix. Entries -3, 2, 20, -10, 9, 18, 11, 15, 12. So let's go ahead and do this determinant again here. So set up your determinant notation for this. Alright, no zero entries, so it doesn't matter which row or column we pick. So let's just do row 1. So we have -3 for our first coefficient. So according to the coefficient matrix, it'll be positive times -3, which would keep it -3. Now we're going to have that times a 2 by 2 determinant. So strike out the column and the row it's in. There's the determinant of what's left. Will be 9, 18, 15, and 12. Let's build this again. Alright, next we're going to deal with that coefficient of 2. We have a positive 2, but according to my coefficient matrix, we need to take negative of positive 2, which would be -2. So we have that -2 times the determinant of what's left over. So strike out the column and row it's in. There's the determinant of what's left. You'll have -10, 18, 11, and 12. Alright, let's rebuild this one more time here. Now let's deal with that coefficient of 20. So we have a positive 20 in this determinant, and according to the coefficient matrix, it'd be positive 20. So that'll be plus 20 times the determinant of what's left over. So strike out the column and the row it occurs in. There's what's left over. -10, 9, 11, and 15. Alright, so now let's deal with our 3 determinants here. So let's take -3 times, let's see, 9 times 12 minus 18 times 15 minus 2 times, let's see, -10 times 12 minus 18 times 11 plus 20 times -10 times 15 minus 9 times 11. All right. So there's the expansion of all those determinants. Now, we have -3 times, let's see, 9 times 12 is 108. 18 times 15, that's a huge number, I could tell you that. 270, 108 minus 270 minus 2 times -10 times 12 is going to be -120. Let's figure out 18 times 11. I want to say it's 198, but I want to be sure. Yep, minus 198 plus 20 times -10 times 15 is negative 150. Minus 9 times 11, that's minus 99. Which will end up giving you, let's see, negative 3 times... Alright, 108 minus 270 is negative 162. Minus 2 times what's inside of here, negative 120 minus 198. Negative 318. Plus 20 times, that would be negative 150 minus 99, that'd be negative 249. Alright, so we're almost there. Let's just do all the multiplication now. So 486 for negative 3 times negative 162. So that should be 636 here, plus 636. Negative 2 times negative 318 is positive 636. And then 20 times negative 249. Wow. Negative 4,980. So let's just add and subtract all this. We'll get a final answer. Negative 3,858. So the value of this determinant is negative 3,858. Yeah, that was awful, wasn't it? And I got one more problem, then we're done for this lesson. Alright, here it is. 3 by 3 matrix with entries 15, 4, negative 10, 0, 6, negative 8, 2, and negative 14. So, good news is in row 2 we have a 0. So we're only going to have to deal with 2 by 2 determinants. So, of course, let me go ahead and set up the determinant notation here. Alright, so let's deal all with row 2. So I'm going to start with negative 10. So according to my coefficient matrix, I need to take negative times negative 10, which would actually be positive 10, times the value of the determinant that's left over. So strike out the column and the row that it lies in. There's a determinant of whatever's left over. So that would be 4, negative 10, and then 2, negative 14. Alright, we just got one more to worry about. Alright, so 0 times anything is 0, but let's deal with that 6. So I have a positive 6, but according to my coefficient matrix, I need to take a negative times that, so that would give me minus 6 times whatever's left over. So strike out the column and the row that it lies in. There's the determinant of what's left. So that would be 15, 4, negative 8, and 2. So now we just deal with two of these 2 by 2 determinants. So we'll take 10 times the first determinant, so 4 times negative 14, minus negative 10 times 2. All that, let's see, minus 6 times the other determinant, so 15 times 2, minus 4 times negative 8. So let's see, let's deal with the parentheses. 4 times negative 14 is going to be negative 56. Negative 10 is actually positive 10 times 2. That would be plus 20. Now minus 6 times what's inside the next one. 15 times 2 is 30. Then we have negative 4 times negative 8. That's plus 32. So let's see. Then we'll end up having 10 times negative 36 minus 6 times 62. Well, 10 times negative 36, that's negative 360. Then we need to take negative 6 times 62. That'd be minus 372. Which would be negative 732. So the value of this determinant would in fact be negative 732. So that's it for this lesson, teaching the determinant of a 3 by 3 matrix with the normal method. Next lesson we will do the determinant of a 3 by 3 matrix using the method of expansion of cofactors. That's a second method. And all these methods we're using for 3 by 3s you can use on 4 by 4s, 5 by 5s, and higher. It's just, if you go to a 4 by 4 or higher, I personally suggest using an advanced graphing calculator to solve it. So I hope everyone has a great day. Take care.